In this section, we learn implicit function because we want to find derivatives of implicit function. So first we understand two types of function, explicit function and implicit function. So first function we already learned. This function is called a explicit function. What is meant by explicit function? A function in which dependent variable say y can be completely expressed in terms of independent variable say x is called explicit function. Means dependent variable say y completely expressed in independent variable only x is called explicit function. Here I am giving example. First example, y is equal to 5x square plus 3x minus 9. Here y can be expressed in only which form? X variable form. It's called explicit function. Second example, y is equal to sin x plus cos x is also explicit function. Why? Because y can be expressed in which variable? X variable, x variable. Therefore it is a type of explicit function. Third example, y is equal to tan inverse x plus e raised to x. Here is x, y can be expressed in only form x variable form. It's called explicit function. In general, therefore we can write in y is equal to f of x is called a explicit function formula. Okay, yeah, it is denoted by just y is equal to f of x form is called explicit function. Now we learn implicit function. So implicit function definition, a function in which dependent variable say y cannot be expressed completely in terms of independent variable means x alone. A dependent variable which cannot be expressed in independent variable x alone, that type of function is called a implicit function. Example, first one, here first example is x square plus xy plus y square is equal to 0. This type of function is called a implicit function. Why? Because here x and y we cannot separate separately, means x in terms of y, yeah, y in terms of x. Therefore we call it implicit function. Second example, cos of xy is equal to x plus y. Here x and y are we can separate, but how to separate cos of xy? Because here is a cos theta function and x and y we cannot separate, therefore it is a type of implicit function. We also write cos of xy is equal to x plus y. Cos of xy, here is plus x, then it becomes minus x minus y is equal to 0. Okay, this is the implicit function. And third example, y e raised to x plus x e raised to y is equal to 1. This example is also implicit function. In general, it is denoted by f of xy is equal to 0. Why? Because this function is always combined form x and y. So therefore we are writing f of xy is equal to 0. Okay. Then my next question is how to solve, yeah, or how to find means dy upon dx means differentiate y with respect to x. But which function? How to solve derivatives of implicit function. Therefore here I am making steps 2. By using these steps 2 we can solve, yeah, we can find derivatives of implicit function. Which function? Derivatives of implicit function. So step number 1. What is step 1? Differentiate both sides. Differentiate both sides of the equation with respect to x. This is step number 1. Differentiate both sides with respect to x. Here one more line. Treating y as a differentiable function of x. Treating y is a differentiable function of x, which means that we can find y derivative with respect to x. Okay, because y is a differential function of x. So this is step 1 complete. Then step 2. What is step 2? Step 2 is collect after differentiating. Step 2, collect the terms containing dy upon dx. Collect the terms containing dy upon dx on one side of the equation. After collecting the terms dy upon dx, then solve for dy upon dx. What is step 2? First, collect the terms dy upon dx on one side of the equation, and last step, solve for dy upon dx. Okay, this by using these two steps we can solve derivatives of implicit function. Okay, let us see problem. Example on implicit function. First question, find dy upon dx if x cube plus x square y plus x into y square plus y cube is equal to 81. Then we want to find derivative dy upon dx. First of all, we identify which type of function. Here we observe that x and y are both combined form. Otherwise, we cannot separate x or y in terms of yx. Therefore, we call it implicit function. Then we use derivatives of implicit function procedure. Its solution. What is first step? First of all, given x cube plus x square y plus xy square plus y cube is equal to 81. First step, differentiate both sides with respect to x. Differentiate both sides with respect to x. Then we get derivatives of whole function x cube plus x square y plus xy square plus y cube is equal to derivatives of 81. So first of all, 81 is a constant term. What is derivative? Constant term derivative is 0. Then derivatives of how many function? First, second, third, fourth. Then first derivative, derivatives of x cube. Then d by dx of means derivative x square y plus d by dx of xy square plus derivatives of y cube. Next step, what is x cube derivative with respect to x? 3x square plus, here we want to find derivatives of x square into y. Which form? U into v form. Here we are finding derivatives of y. Why? Because y is also differential function of x. Therefore, we are taking here u into v rule. What is u into v rule? First function is x square as it is. Second derivative, what is second? Y plus y as it is. First derivative, what is first? X square. Then this step is complete. Plus next function is derivatives of x into y square. So here is also again use u into v rule. So first one is x as it is, derivatives of y square plus y square as it is, derivatives of x. First function is x. This process is complete. Then derivatives of y cube with respect to x. Therefore y is a composite function with respect to x. Therefore y cube derivative 3y square into again y derivative by using chain rule. Okay. Then after simplify, x square here dy upon dx plus y as it is, derivatives of x square, derivative of x square is 2x. The 2yx, okay, plus x, y square derivative 2y into dy upon dx plus y square as it is, derivative of x is 1 plus 3y square into dy upon dx is equal to 0. Okay, step 1 is clear. Then we move to the step number 2. What is our step 2? Step 2 is for collect the terms containing dy upon dx. So here is dy upon dx, dy upon dx. How many times? 3 times. Collect all the terms dy upon dx one side. First, x square dy upon dx. Second one, here 2xy dy upon dx. Then third one, 3y square dy upon dx. First we collecting the term dy upon dx, then remaining term add. Which term? First term is 3x square, then skip this term, then 2xy, then y square. Okay, all terms are collecting without dy upon dx is equal to 0. Then after collecting, here dy upon dx is taking common, dy upon dx taking outside the bracket, then remaining terms x square 2xy plus 3y square bracket complete plus 3x square 2xy plus y square is equal to 0. The next step is only for solve for dy upon dx. Therefore here we can find only which form? Dy upon dx form. Therefore this term as it is, which term? X square plus 2xy plus 3y square as it is equal to, here is plus sign. If we move this bracket full term to the right side, it becomes minus 3x square plus 2xy plus y square is equal to this term as it is, minus 3x square plus 2xy plus y square upon which term? This term is numerator form. If you move to the right side, it becomes which form? In denominator place. What is x square 2xy plus 3y square. Therefore we get required solution dy upon dx. This is the required our solution. Okay, then we move to the question number 2, which depends on implicit function. What is given? If log of x cube minus y cube upon x cube plus y cube to the base 10 is equal to 2, then show that. What show that? Its derivative dy upon dx, y with respect to x, is equal to minus 99x square upon 101 y square. Okay, first of all, what is given? Given log of x cube minus y cube upon x cube plus y cube to the base 10 is equal to 2. After simplifying this equation, you will get, you will want dy upon dx is equal to minus 99x square upon 101 y square. And how to find? First of all, we use here log property. What is log property? Log property is which property? Log property, log m to the base a is equal to n. Which form? Log m to the base a. Log this bracket to the base 10 is equal to something, means 2. So this formula is same as it is. So which change is possible? we can change m is equal to a raised to n. M is equal to a raised to n by which definition? Log definition. Therefore we changes here same as it is, m raised to n. What is mean by m? M means this term, a means 10 and n means 2. Therefore implies x cube minus y cube upon x cube plus y cube means m is equal to a raised to n. A raised to n. Therefore here 10 raised to 2 means 10 square is 100. Therefore we get x cube minus y cube is equal to, here is 100 into x cube plus y cube. Again simplifying, 100 multiply in bracket 100 x cube plus 100 y cube, x cube minus y cube. Here is x cube and again x cube. Here y cube, 100 y cube. Here is minus y cube. Then collect the terms like terms. Here 100 x cube minus, here is plus x. If you move to the other side, it becomes negative, minus x cube. Then minus y cube as it is. Here is plus 100 y cube. If you move to the other side, it becomes negative. Here is plus. If you move to the left side, it becomes negative. 100 y cube is equal to 100 x cube minus x cube. 100 x cube minus 1 x cube, we get 99 x cube. Here minus minus, we get minus, but addition plus. Y cube, 100 y cube, 101 y cube. Again we can simplify, y cube is equal to minus 99 upon 100, sorry not 100, 101 into x cube. What is here? Y cube is equal to minus 99 upon 101 into x cube. So which form? Y is equal to f of x form. Therefore here we can differentiate. We want to find dy upon dx. Therefore our given equation is which form? Y is equal to, y cube is equal to minus 99 upon 101 into x cube. Therefore we differentiate both sides. Differentiate on both sides with respect to x. We get y cube derivative. Y cube is a composite function. Y cube derivative is 3y square into dy upon dx is equal to minus 99 upon 101 is constant term into derivative of x cube. What is derivative of x cube? X cube derivative is 3x square. Here other side is 3y square into dy upon dx. Let us see which terms are cancel possible. Here 3 are same, then cancel. Okay, no any other term cancel. Therefore we get dy upon dx is equal to, here y square is equal to minus 99x square upon 101. Here is y square in multiplication form. If you move to the other side, it becomes in denominator form. Therefore dy upon dx is equal to minus 99 x square upon 101 y square. Therefore we get our required solution. Okay. Here I am given some example homework questions on implicit function. Question number first, find dy upon dx if, first question, e raised to x plus y is equal to cos of x minus y. By applying implicit function procedure, you can find its derivative by dy by dx. Then second question, x plus root of xy plus y is equal to 1. Here you say that both functions are available x and y form. Therefore, you are applying strictly differentiate with respect to x on both sides. Then question 2. What is question 2? If x raised to y is equal to e raised to x minus y, then you have to show that dy upon dx is equal to log x upon 1 plus log x bracket square. We just discussed on hint how to solve it. What is given? Given x raised to y is equal to e raised to x minus y. Then which type of function? Implicit. Okay, then differentiate. Differentiate means, yes, taking log on both sides, we get log x raised to y is equal to log of e raised to x minus y. By log property, y into log x is equal to x minus y into log e. What is log e? Log e's value is 1. So we get x minus y as it is, y into log x. We combine the y terms, y into log x. Here is minus, then it becomes plus y is equal to x. Then take y as a common, then remaining term log x plus 1 is equal to x. Therefore we get y is equal to x upon log x plus 1, here 1 plus log x. Then which form? Y is equal to completely x form. Y is equal to which form? F of x form. So this is not implicit function. Which form? This is a explicit function. Then differentiate y with respect to x, you will get this form answer. Okay.